Good morning, girls. As we have discussed, semester 1 statistics paper consists of 4 units. Unit 1, 2, 3, 4. The title of the paper is Descriptive Statistics. Descriptive Statistics and Probability. From the now onwards, each paper is going to have a title. Okay. So semester 1, you'll call that as S1 statistics first paper. As I have said you that you'll have on the whole 6 papers you are going to read. So this comes under S1 paper. The title of the paper is Descriptive Statistics and Probability. So take out, as I have already sent you the syllabus, take out the syllabus. Okay. Just I'll discuss the syllabus and then I'll enter into unit 1. So if you go to unit 1, it consists of primary, secondary data, questionnaire schedule. Then it comes to the measures of central tendency and measures of dispersion and measures of skewness and kurtosis. So unit 1 mainly consists of primary data, secondary data, questionnaire, schedule, central tendency, dispersion and skewness and kurtosis. Unit 2 consists of probability, which involves the definitions of probability, addition theorem, multiplication theorem, Bayes inequality and Boole's inequality. And unit 3 consists of random variables, one-dimensional random variables, types of random variables. Unit 4 consists of generating functions and mathematical expectations. So your syllabus consists of 4 units. Unit 1 consists of measures of central tendency, dispersion, skewness and kurtosis. Unit 2 consists of probability, certain theorems on probability. Unit 3 consists of random variables, types of random variables and problems on that. Unit 4 consists of mathematical expectation. Now, to start, as you have know that don't think that always statistics consists of only numerical problems. As I said you that you'll have both theory paper and practical paper. In the theory paper, we are going to deal only with derivations and theorems from here onwards. I think I have learned statistics in the school days, where statistics always means numerical problems only. Calculation of mean, calculation of median, mode. Not only those, many more you are going to learn. Moreover, from here onwards you will have 2 papers called theory paper and practical paper. Under theory paper, we are going to deal only with theorems, definitions and derivations till the end of your final year. Under practical, you are going to do the corresponding numerical problems. Try to identify the difference between these two, because every year generally student tries these questions only. Do we get numerical problems for theory? There is no chance of getting numerical problems in the theory paper. In the theory paper, exclusively you will get only theoretical part called derivations, whatever it may be. All the numerical problems you are going to get only in practical one. First of all, try to identify the theory and practical paper. So if you go to the unit 1, let us start with unit 1. Unit 1, the first 2 lines are nothing but primary data, secondary data and questionnaire, schedule, classification and tabulation. Girls, that is purely theory part. Every year I will do the same. That theory part will be discussed after completing the entire syllabus. I'll start with, because students are easy to understand this. If I start the theory at first, you may not understand anything. Let us start with measures of central tendency. Measures of central tendency. So, what are measures of central tendency? Measures of central tendency means, suppose that you are given with this. I said you that statistics is nothing but collection of data, analysis of data and interpretation of data. So whenever you have data, okay, so suppose that if I say that I'll give you an example what is meant by central tendency. Central tendency is nothing but it is a single value with which you are going to represent the entire data. So whenever you are given a series of observations, okay, suppose that you are given 50 observations. Now I think each and everywhere you cannot use all the 50 observations. You are going to represent all these 50 observations with a single value, which is called measures of central tendency. Central tendency means it is a center value or a single value with which we indicate entire data. I'll give you a small example. Suppose that I think you have cleared your intermediate examinations, okay. So you have 3 optionals: mathematics, physics, chemistry and all, languages and all. So in general, if they ask about the questions regarding your marks, what you will conclude that I got 74% or 7 points. Means even though you have list of marks there, under mathematics you got out of 75, let us say you got 60 marks, 40. You have list of marks there, but if I ask you how many marks you got or what is your percentage, I'll ask, means you are representing entire year report with a single value. I got an aggregate of 7 points, or I got 80%, I got 90%. Means instead of representing the entire data each and every time, we are going to represent the data with a single value, which is called measures of central tendency. So and also the best examples also, I think recently you have started your classes, online classes. Madam may observe that on an average how many students are attending daily. So the entire BSc strength is, let us say, 30 students are there. So I think every day, I think maybe one day the present is at 10 students first day have attended, and the other day 13, again decreased, again increased. Means let us say these are nothing but number of students attending the classes out of a week. In a week after the observation, they came to know that these are the number of presentees in each class. So I think they use a single value for this. After finding the average, they say that out of 100%, 74% students are attending the classes. Means whenever you have a collection of data, whenever you have a simple word series of observations, to represent them with a single value, we are going to use the measures of central tendency. Means we can define measures of central tendency as the single value around which all the other values may concentrate or may fluctuate. Now, what are the different measures of central tendency you have? Mean or arithmetic mean. You know this. Arithmetic mean, median, mode, geometric mean, which we indicate with GM, harmonic mean. So we have 5 measures of central tendency: mean, also called arithmetic mean, median, mode, geometric mean, harmonic mean. These are the different central measures of central tendency available to us. Now, why we have different categories of central tendency? Whenever we have different options or choices, it means that mean is not applicable to all kinds of data. Median is not applicable to all kinds of data. Similarly, the other also. Means why we have these varieties of central tendency? Because mean cannot be used for all the kinds of data. Similarly, median means there is a specific application for each of these measures of central tendency. Before going to that, let us discuss, before going to do the numerical problems or any other, let us divide the data into different types. Data generally divided into 2 types called ungrouped data, which is also called raw data. Okay, raw data. The other one is nothing but grouped data. Generally, the data is of 2 types: ungrouped data, which is called raw data, grouped data. Under this again you will find 2 varieties called discrete and continuous. Even though these terminology is looking different, all these you have already learned in the school days or during your intermediate classes. Whenever you have data in this type, I think only observations are given to you. We call these as ungrouped data. Okay? Whenever you have data in the form of table with two columns, like one of the column as the variable, other as frequency, we call this as grouped data. Ungrouped means we will have only single row or single array of observations. Only a single array or say a group of observations with no grouping, like 10, 17. Some observations are given in a single line, which we call that as ungrouped or raw data. Whenever we have data in a form of table with two columns, with one representing as the variable and other as the frequency, we call that as a grouped frequency distribution. Again, I said you that grouped frequency is of two types, discrete and continuous. Whenever this variable has only single observations, got the difference between grouped and ungrouped? Under ungrouped data, you don't have any frequencies, only single array of observations means grouped. No doubt, no, I think it is clear. Under grouped frequency, you are going to find data in two columns, as one of the first column always represents variable, second one indicates the frequency. Again, this we call as grouped one. Under this again, whenever the observation takes a single variable takes single value, under x column we have only 20, single value here, single value, single value, single value with the respect to frequencies. We call this as discrete distribution. Whenever we have two columns, that we call as grouped one. Unlike that, you have a class interval there here. So whenever we have on the variable, it assumes a range of values between 0 to 10, 10 to 20, 20, 30. We call that as a continuous frequency distribution. This is ungrouped. These two comes under grouped one. Under grouped one again, whenever a variable assumes single values, we call this as a discrete distribution. If at all it assumes the values between a range, we call this as a continuous distribution. Why we are discussing all these means, whatever we have discussed just now, measures of central tendency, you will find different formulas for those. Those formulas are going to change depending upon the type of data. What is the first measures of central tendency we have observed? Mean, which is also called arithmetic mean. Okay, so what is arithmetic mean? How do you define the arithmetic mean? Means sum of the observations by number of observations is called arithmetic mean. Now you should write the formulas for three types of data: grouped data, and that for ungrouped data, and also for grouped data. The very first measures of central tendency is arithmetic mean. That arithmetic mean, you should write the formula. You know that sum of the observations by number of observations is called arithmetic mean. That is the basic formula for this. But notation wise, you are going to have different formulas for ungrouped data and grouped data. Let us see what is ungrouped data. I said to you that ungrouped data means you will have number of observations on a single observation. This represents the ungrouped data. So what is sum of the observations? Sum means x1 plus x2 plus so on xn by number of observations n. Okay, so whenever these are separated with plus, we indicate that with sigma xi by n. This stands for mean for formula under ungrouped data. Ungrouped data means no frequencies are attached. We will have a number of observations, which we call that as ungrouped data. There the formula is sum of the observations by number of observations, which is nothing but sigma. This we pronounce as sigma, and which stands for the total or the sum of the observations. N stands for number of observations. Now, what is the frame of grouped data? You'll have in this way grouped one, where you'll have two columns. One of the column represents the variable x, and the other column indicates frequency f. If it is discrete one, okay, you'll have here x1, x2, so on xn. Discrete meant what I said, you'll have a single values x1, x2, xn. Let us say that f1, f2, f3 or fn are the corresponding frequencies. Now, to calculate mean for this, the formula which we indicate mean with x bar is equal to, here what you have, sigma. Okay, you write the same. Just I am telling how to write the formula from ungrouped to grouped. Try to understand. You have only xi here. Am I right? Sigma is common to you. Sigma. In place of xi, you attach f also. Fi xi by. Here you are writing n. You write that with small n here stands for number of frequencies, number of observations. Capital N is nothing but total of frequencies. So x bar for grouped data is nothing but, try to remember the formula here, sigma xi by n, sum of the observations by number of observations. If you want to calculate that for discrete grouped one, this is the frame of the table. Sigma is as it is. In place of x you will get fx. Means fx means f into x. To calculate that, you should add one more column for the given data. You should find out fx, multiplication of the corresponding x and f values. Find the total of this column, which represents sigma fx by n. Capital N here stands for total of the frequencies. There n stands for number of observations. This is the case when we have the discrete one. When you have the continuous one, continuous means you will have two columns. The first one which we call as the class interval, second one we call as the frequency. So class interval means you will have a lower limit and upper limit. Lower limit to upper limit. Ln to un. F1, this is the structure of the continuous frequency distribution. What is the difference between discrete and continuous? Under discrete, under each variable you will have the single values. Under continuous variables you will have a lower limit and upper limit. No change in the formula, sigma fx by n. But here you can directly multiply these two. If you take the same example here, the data given to you is this. Simple example I am considering. You can multiply to get fx column. 20 into 120, 60, 320, 400. You will add all these values. This is 720. 720 plus 60, 780. 780 plus 20, 800. And the total of these is 19. So here you are able to multiply these two. So under continuous one, as you have a interval here, 0 to 10, 10 to 20, 20 to 30, even though there is no change in the formula, you cannot multiply. 4 into 10, 0, 10 you cannot multiply. So to calculate the mean for continuous one, first you convert that continuous distribution into discrete distribution by considering the mid values for the class interval. So how do you get the mid values? Lower limit plus upper limit by 2. Means there is no change in the formula for continuous one. X bar is equal to sigma fx by sigma f. Here x stands for the mid values of class interval. Then once it is converted into discrete one, you will follow the same with the discrete one. Okay. Now let us discuss the problems in the simple problems on this in the next class. Okay, thank you.